My grandpa, Arthur Hoffer, built the first Rubik's Cube and had many other amazing accomplishments in his life. He is the smartest man I know. 7 years ago, my grandpa was diagnosed with Alzheimer's disease, and now, at age 77, he's at a stage 6 out of 7 on the Alzheimer's scale, with 7 being the worst. He can't really talk anymore or do mostly anything by himself. He still loves to dance. The video I am playing in the background is of me, Emma, and my grandpa dancing, which is his favorite thing to do. This horrible disease took away one of the most important things in my grandpa's life, his brain. It's not fair, and currently there is no cure, but what if there was? We are going to talk about a new prenatal test, which can tell if your child could develop early onset Alzheimer's disease. First, let's discuss what Alzheimer's disease is. Disease is an irreversible and slow-processing neurological disease that destroys memory, thinking skills, and eventually the ability to do simple tasks. It currently affects over 5 million Americans, and symptoms first appear in their mid-60s. It's the 6th leading cause of death among U.S. adults and the 5th leading cause of death among adults aged 65 and older. Estimates vary, but experts suggest that more than 5.5 million Americans may have Alzheimer's. Plaques and tangles play a big role in the cause of Alzheimer's disease. Plaques are deposits of a protein called beta amyloid. When an A-beta molecule clumps together in the brain, they form plaques, which prevent signals from being transferred between nerve cells in the brain, ultimately causing the cells to die. And tangles are fiber clumps of a protein called tau. In unhealthy brain areas, the tau protein collapses and twists, forming tangles which prevent nutrients from reaching brain cells, resulting in death. Alzheimer's is affected greatly by the APOE gene. There are 3 main variants of the APOE gene that have been connected to Alzheimer's disease. They are APOE2, APOE3, and APOE4. APOE2 is very rare, but it has been seen to protect against the disease. APOE3 plays a neutral role in the disease, and the APOE4 gene has been seen to be correlated to early onset Alzheimer's disease. However, having the APOE4 gene does not guarantee that the person will develop Alzheimer's disease. Who do develop Alzheimer's tend to get it earlier than patients with no copies of the APOE4 gene, and people with 2 copies of APOE4 tend to get Alzheimer's earlier still. For our genetic test, we decided to do a prenatal test on a fetus to see if there is a likelihood for the development of Alzheimer's disease. The genes we will test are associated with early onset Alzheimer's disease. The early onset form of Alzheimer's disease is inherited in an autosomal dominant pattern, which means 1 copy of the altered gene in each cell will increase the likelihood of developing the disorder. The genes we'll be testing are the APOE gene and the APP gene, because they are the most reliable predictors of genetic risk for this trait. That's why we picked these genes. For the APOE gene, we will test 2 variations of this gene, which are APOE2 and APOE4. The APOE4 variation increases risk for Alzheimer's disease and is also associated with an earlier age of disease onset. Having more APOE4 alleles increases the risk of developing Alzheimer's disease. The APOE2 allele is relatively rare and could provide some protection against the disease. If Alzheimer's disease occurs in a person with this allele, it usually develops later in life than it would with someone with the APOE4 allele. The second gene we're going to be testing is the APP gene, and it has 50 different variations. APP is widely expressed in tissues and is particularly expressed in the synapses of neurons. APP is thought to be responsible for forming and repairing synapses. Mutations of the APP gene have been associated with Alzheimer's disease, and in particular, early onset Alzheimer's. As previously mentioned, a primary cause of Alzheimer's disease is plaque, which is made up of the amyloid beta protein. Mutations in the APP gene can lead to an increase in production of the protein. More than 20 mutations of the APP gene have been found to increase the likelihood of the development of early onset Alzheimer's disease. Recent evidence suggests that APP has growth-promoting properties and may play a role in the formation of neurons in the brain, both before and after birth. We will use a SNP test on both of the genes we are testing, but what makes this test so amazing is that we do conventional gene testing also. We believe these genes are the most logical to test because they both test for early onset Alzheimer's disease.
As mentioned, plaques and tangles inhibit the function of brain cells and vital processes, which is associated with Alzheimer's disease. The rate at which medical advances are occurring leads us to believe that in the near future, researchers will develop drugs to prevent plaque buildup and tangle formation. In this way, brain cells will retain their ability to transmit signals and receive nutrients, thus preventing the onset of Alzheimer's disease. The earlier a person starts taking the drug to prevent plaque and tangle damage, the more time it has to prevent the possible onset of Alzheimer's. We have designed a test to determine what variations of the APOE gene and the APP gene a baby may have, and thus any likelihood of developing Alzheimer's disease in the future. This is beneficial because if mothers are aware of their child's likelihood of developing Alzheimer's later on, the child can begin taking the preventable drug at an earlier age. According to the highly credible source SNPedia, a person with the APOE4 variation is about 15 times more likely to develop Alzheimer's than a person with the APOE3 variation. The APOE2 variation, however, is associated with the lowest risk for developing the disease. While researchers are unaware exactly how much the variations of the APP gene increase Alzheimer's risk, we do know that APP variations can lead to the buildup of amyloid plaque in the brain.
We know that limitations to testing can be very tricky to understand for the patient. Therefore, our company makes sure to completely elaborate upon the implications of each of three possible results to our patients. The first, a positive test result, means that the laboratory found a change in a particular gene, chromosome, or protein. This result indicates that a person is a carrier of the Alzheimer's gene mutation or identifies an increased risk of developing Alzheimer's. We also keep in mind your loved ones. Because family members have some genetic material in common, a positive test result may also have implications for relatives as well. Testing family members helps us with the second implication, inconclusive test results. Sometimes a test result might not give any useful information because everyone has common natural variations in their DNA called polymorphisms that do not affect health. Polymorphisms make it difficult to tell whether it is a natural variation or a disease-causing mutation. Therefore, testing other affected and unaffected family members can help to clarify this type of result. The third and final result is a negative test result. This means that the laboratory did not find a change in the gene, chromosome, or protein. Good for you. You're not a carrier, nor do you have an increased risk of developing Alzheimer's. Our company is super open about disclaimers because we want the absolute best for our patients. We are definitely informing you that a positive result of a predictive or pre-symptomatic genetic test usually cannot establish the exact risk of developing a disorder. Also, health professionals typically cannot use a positive test result to predict the course or severity of a condition. And testing negative may still require further testing to confirm the result because it is possible that the test missed a disease-causing genetic alteration. Many tests cannot detect all the genetic changes that can cause a particular disorder. There are also scientific reasons why someone should not take this test. According to nogenetics.org, an overestimation of the role genetics plays in different diseases sometimes occurs. While the amount that genetics contributes to a trait varies, very few traits and diseases are controlled strictly by genes, Alzheimer's included. Most traits are also affected by environmental factors and lifestyle choices. Because DTC genetics companies are relatively new, the government has not yet determined how to best regulate them. This lack of oversight of the companies results in many reputable companies with quality service and reliable results, but other companies may make false claims and use faulty practices. It is up to the consumer to distinguish the good from the bad, which can prove to be risky.
Participants may feel a wide range of emotions, including anger, depression, and guilt after receiving difficult news, since genetic tests are offered for terminal conditions. A positive prenatal test result creates additional ethical decisions, including pregnancy termination. When our test first hits the market, it may pose financial limitations. However, testing your fetus to see if it has Alzheimer's disease really benefits the whole family. If there's a new drug that can help stop Alzheimer's when given to a young or unborn child, why wouldn't people want to try it? Or if there are other ways to at least decrease the chances of getting the disease, wouldn't someone want to try it?